For AP Chemistry. This tutorial is going to go fast, so you should stop anything that you need to write down. The key to the presentation. Green information is new. Anything in red is for formulas for naming, and black should all be review information. Naming ionic compounds. An ionic compound is a nonmetal and nonmetal, and there are two parts to it, a cation and an anion. A cation is when a metal loses valence electrons to become positively charged. So most metals who lose valence electrons come from group 1A, 2A, and 3A, and they form cations that are equal to their group number. So anything in group 1A are going to have are going to lose valence electrons, resulting in a +1 charge. Anything in group 2 are going to lose valence electrons and have a +2 charge, and anything in group 3, which basically is aluminum, tends to lose 3 valence electrons, resulting in a +3 charge. And the cation name equals the metal name plus the anion name. Sorry, the cation name. Naming ionic and monatomic ions. An anion is a negatively charged ion. The charge of an anion is determined by subtracting 8 from the element's group number. So the name of a nonmetal anion is the stem of the name plus the suffix IDE plus ion. So for determining the anion name, you take the element's group number, so let's say it's group 8, and you subtract 8 from that, and you get a charge of 8, or 0. So metals that form more than one ion, the charges of any, which is basically any transition metal, must be determined from the number of electrons lost. So the stock naming system is the name of the ion equals the cation plus the Roman numeral of the charge value plus the anion plus the suffix IDE. So the Roman numeral of the charge value is literally a Roman numeral that carries the value of the cation charge. So naming polyatomic ions. A polyatomic ion is an ion that is composed of more than one atom. It still carries a charge and either has the suffix "ite" or "ate". The suffix "ite" indicates one less oxygen atom than the suffix "ate". Both suffixes contain oxygen atoms. So the polyatomic ion name equals learn the number of oxygens for 8 and the suffix, and the "ite" is for one less. The per prefix 8 suffix is one more than the 8 suffix, and hypo prefix "ite" suffix is one less than "ite". Okay, so that sounds a little bit confusing. So any compound that has a per prefix and an 8 suffix has one more oxygen than a compound with just an 8 suffix. And a hypo prefix and an "ite" suffix compound has one less oxygen than a "ite" compound. Okay, naming compounds and binary ionic. So a binary compound composes of two elements. It can either be ionic or molecular, and a binary compound name equals the cation name plus the anion name. Roman numerals are needed for transition metals, for all transition metals except for CD, ZN, and AG. So here are naming ionic compound examples. So KCl, so the cation, you first need to identify the cation. The cation is potassium, as seen in the K. The anion name is Cl, which is chlorine, which comes from Cl-. So potassium plus chlorine plus the IDE suffix equals potassium chloride. And we need to identify the cation, which is Cu+, which is copper, and the anion, which is S-, which is sulfur. And we put copper plus Roman numeral 2. And the Roman numeral 2 comes because copper can take more than one charge value. And you do sulfur plus IDE suffix equals copper 2 sulfide. Okay, so looking for the copper 2, if you look at the chemical formula, you see that it's CuS2, and the S subscript 2 indicates that the copper is taking a plus 2 charge, indicating that it needs a Roman numeral of 2. LiSO4, the cation name is lithium, comes from Li+, and the anion name is sulfate, which comes from SO4-. So lithium plus sulfate equals lithium sulfate. So this is naming ionic compounds practice. You should pause the video now and try to solve these for yourself. Naming molecular compounds, binary compounds. So a molecular compound is a metal and a non-metal. The prefix indicates how many atoms of an element are present in a compound, and the prefix comes from the subscript. So a prefix comes from the subscripts is referring to the chemical formula. So when you're looking at subscripts, the subscript that is on a part of the compound indicates what prefix it should have. So steps to naming a binary molecular compound. Write the names of an element in the order given in the formula. Add prefixes. Do not add a prefix mono to the first element in the name of any compound. End name with the suffix IDE. So, as you can see over on the left, there's a chart. So this chart indicates the prefix that goes along with the number of the atoms within the element. This is also referring to any subscripts. So binary molecular compound name equals the prefix plus the element name plus the prefix plus the element name plus the suffix IDE. So here's some practice. So we see SO2. So sulfur and oxygen come from both the cation and the anion, and the sulfur it just takes its name sulfur. But we also see that the oxygen has two subscripts. This points us to adding a di, which is a 2 prefix, to the oxygen, and in addition to the IDE suffix. So we result in a sulfur dioxide. Some may think that this would be monosulfur dioxide, but this is incorrect because no compound takes the prefix mono in the first element. So we also have CO. So we identify that it's carbon and oxygen. Carbon also has the prefix of 1, but we don't include that. Plus the oxygen has a prefix of 1 plus the IDE. So we get carbon monoxide. And now we have N2O5. So we identify that it has nitrogen and oxygen, and nitrogen takes the prefix di because of the 2 subscript on it, and oxygen takes the prefix penta because of the 5 subscript on it, in addition to the IDE suffix. So we get a name of dinitrogen pentaoxide. So here you should also pause the video and see if you can name these following molecular compounds. So now we're into naming acids and bases. An acid is a compound that contains one or more hydrogen ions when dissolved in water. So an anion suffix in this chart is shown by the IDE, ite, or ate suffix. And in the IDE ending, you go to the naming formula, which has a prefix of hydro and a suffix of ic in addition to acid. And for an ite anion suffix, the suffix on the acid would be us and acid. And a suffix of ate on an anion would result in a suffix of ic on an acid name. And a base is a compound that reacts with an acid to form a salt. And the bases are named as other ionic compounds except the name of the cation is followed by the name of the anion. Okay, so naming acid examples. So we have HCl. and we obtain that hydrogen is the cation name and chloride is the anion name. So because it ends in an IDE suffix, we go with the prefix hydro plus chloride plus ic suffix plus acid to get hydrochloric acid. And then we also have HNO3, and we notice that the cation is once again hydrogen, but the anion is nitrate. So we add a ic suffix in addition to acid to form nitric acid. And we also have H2SO3, and we identify that hydrogen once again is a cation name, and sulfite is an anion name. So we notice that the sulfite has an ITE or ite ending on it, resulting in a OUS or us suffix in the sulfurous acid. Okay, so you should once again pause the video for this and practice your naming of acids. So now we have some real world connections. So basically, why do I have to know how to name compounds? Well, there's some compounds that are found in household items such as CHNaO3 is sodium bicarbonate, which is also Alka-Seltzer. CnH8SO4 is acetylactic acid, which is aspirin, and NaClO is sodium hypochlorite, which is bleach. And CaCO3 is calcium carbonate, which is chalk. Naming these compounds would help you identify what's in everyday household items, which may or may not help you in your decision of purchasing household items. Thank you for watching, and hopefully this helped you.